करके क्वेश्चन डिस्कस करेंगे सेक्शन वाइज। सेक्शन ए, फर्स्ट क्वेश्चन is a biconvex lens of glass having the refractive index 1.47 is immersed in a liquid. It becomes invisible and behaves as a plain glass plate. The refractive index of the liquid is. So I think everyone know the lens maker formula. तो यहाँ पे दे रखा है कि इमर्स करने के बाद वो इनविजिबल एंड प्लेन ग्लास प्लेट जैसा बिहेव कर रहा है, मतलब उसका फोकल लेंथ क्या हो गया, इंफिनिटी। तो लेंस मेकर फार्मूला से 1/a μ2 by μ1 minus 1 1/r1 minus 1/r2, right? This will becomes infinity if this will become 0. So μ2 minus μ1 minus 1 is equal to 0. That is μ2 is equal to μ1 is equal to 1.47. Okay. Now next question is, these are objective questions. For a glass prism, the angle of minimum deviation will be as smallest for the light. So for angle of minimum deviation in case of prism, mu is equal to sin a plus delta min by 2 divided by sin a by 2. तो डेल्टा हमको म्यू डेल्टा मिनिमम डेविएशन को मिनिमम करना है, मतलब म्यू को मिनिमम करना पड़ेगा। और आई थिंक एवरीवन नो म्यू इज इनवर्सली प्रोपोर्शनल टू लैम्डा। तो जिसके लिए डेल्टा मिनिमम को कम करना है तो म्यू को कम करना है, तो डेल्टा क्या होना, लैम्डा क्या होना चाहिए, म्यू मिनिमम के लिए लैम्डा मैक्सिमम होना चाहिए। किसके लिए होगा, रेड कलर, इस ऑप्शन ए। अब नेक्स्ट क्वेश्चन है, which of the following statement is not correct according to Rutherford model? First is, most of the space in the inside an atom is empty. It is a correct statement, but question asked is not correct. Second option is, the electron revolve round the nucleus under the influence of Coulomb's force acting on them. So this is actually Bohr's postulates. Option C is, most part of the mass of the atom and positive charge are concentrated at its center. It is also a correct statement. The stability of atom are established by the model. No, this is the incorrect statement. Actually option D is correct. Now question 4, photon of energy 1 electron volt 2 and 2 electron volt are successively incident on a metallic surface of work function 0.5. The ratio of kinetic energy of the most energetic photon in the two cases will be. तो ये क्वेश्चन एक्चुअली फोटो इलेक्ट्रिक इफेक्ट से है। तो आई जो फोटो इलेक्ट्रिक इक्वेशन है दिस न्यू नॉट प्लस हाफ है v स्क्वायर। दिस इज एक्चुअली वर्क फंक्शन प्लस काइनेटिक एनर्जी, दिस इज द इंसिडेंट energy of photon. So first, the one electron volt, the energy of photon energy is first is 1 electron volt and the work function is 0.5 k. So k will become, this is also in electron volt, this is will become, suppose this is k1, the k1 will become 0.5 electron volt. Now similarly k2 becomes 1.5 electron volt. The question is, kinetic energy of most energetic photoelectron in two successive cases. Two most energetic photoelectrons in two, so k1 by k2 will become 0.5 by 1.5. This is 1 by 3. This is option C is correct. Now question 5, the magnetic dipole moment of a current carrying coil does not depend upon. So I think everyone know if current I is flowing in a current loop, then magnetic moment M is I into A. I number of turn of the, if there is any turn, the number of magnetic moment become NIA. Okay. First option is number of turn of the coil. It is correct, but question is does not depends upon. The cross section area of the wire, them depend upon cross section area. Now third option is current flowing in the coil. It depends upon the current flowing in the coil. And D option is material of the turn of the coil. No, it's depend upon the number of turn of the coil, not on the material of the turn of the coil. So option D is correct. Now we have question 6. The conductivity of the metal decreases with increases in temperature on account of. Question 6 is conductivity is equal to 1 by resistivity. Or resistivity, I think everyone know, electric field per unit current density. Final expression is m n e squared tau. Right? This is the carrier density, charge on electron, or relaxation time. So I am reading the options. First option is decreases in number density of electron. So if you increase the number density of electron in n, rho decreases. So first option is decreases in number density of the electron. If you decrease the n, rho will increase. But question is about decrease. Second option is decrease in resistivity. If we decrease the resistivity, conductivity increases. Now C option is decrease in relaxation time. If you decrease the relaxation time, the resistivity increases, so conductivity increases. So option C is correct. Okay. Now question 7. Two unequal resistors are connected in series across a battery. Then unequal resistors are connected in series across a battery. Then the first option is unequal resistance. Two unequal resistance, suppose this is R1, this is R2, connected across a battery. First option is, it is given that R1 is not equal to R2. First option is potential difference across each resistor is the same. So since both the resistance are in series, the current in the both the resistor will be same. So potential difference V is equal to IR, but since I is same but R is different, so potential difference across each resistor will not be same. Now option B is current in the smaller resistor is larger. This is incorrect since current in both resistors is same. C is potential difference across the bigger resistor is greater. So suppose R2 is greater than R1 and current in both the resistor is same. So according to Ohms, V is equal to IR, I is same, R is different. The larger the value of R, greater will be the potential difference. So option C is correct. Next, a point charge is situated at an axial point of a smaller electric dipole at a larger distance from it. The charge experiences a force F. If the distance of the charge is doubled, the force acting on the charge will be. So this is electric dipole moment, two charges. Now electric field at the axial position, suppose at a distance x from the center, P is equal to 2kp by r cube. P is the dipole moment and r, suppose this is r is the distance from the center of dipole. Okay. So first option is the potential, the charge experience positive, the force is equal to Q into E. The F is directly proportional to 1 by R cube. F is directly proportional to 1 by R cube. If the distance is double, then f will becomes f by 4. Since suppose this is f1, now distance becomes double. This will become 1 by 8 r cube. So f2 will become f by 8. That is f2 is equal to f1 by 8. So f1 is f, so it will become f by 8. So option D is correct. Now we have question 9. If the net electric flux through the closed surface is 0, then we can infer first option is no charge is enclosed by the surface. Through a closed surface, net flux is equal to charge enclosed divided by epsilon naught. No net charge is enclosed by the surface. This is the no net charge. This is the correct statement. So option A is correct. Question 10. The focal length of objective of a compound microscope is, so in case of compound microscope, it is greater than the focal length of eyepiece. Option A is correct. Now we have fill in the blanks questions. The first question is the number of turn of the solenoid are double without changing its length and area of cross section. The self-inductance of solenoid becomes. So self-inductance in case of solenoid is L is mu naught n square L. N is number of turn per unit length. L is length of solenoid. Now number of turn of solenoid are double without changing its length and area. So we can write also in terms of mu naught n square A by L. So now number of turns is double, so L becomes 4 times. It's 12. According to Bohr's atomic model, there is the circumference of electron orbit is always m. So according to Bohr, circumference of electron orbit, that is 2 pi r, is in lambda. So it is integer multiple of de Broglie wavelength. Now next question is, if beta decay, the parents and daughter nuclei have the same number of. Suppose X is the parents nucleus having mass number A, atomic number Z, it goes through beta decay to beta minus 1 0. So any type of to decay, the mass number or charge number must be conserved. So mass number is here A, here also A. Here mass number is Z in reactant side, but in product side mass number is Z minus 1. So question, beta decay, the parent and daughter nuclei have the same number. So parents and daughter nuclei have same number of mass number. Now question 30. A ray of light on passing through equilateral prism suffer a minimum deviation equal to angle of prism. The value of refractive index of the material of the prism. Prism, equilateral prism. Suppose this angle is A, this is also A, this is also A incident ray, this is the emergent ray. The value of refracting index of material of the prism, it is given that minimum deviation equal to the angle of prism. It is given that delta minimum is angle of prism, that is A. So question is about the refractive index. So mu is equal to sin A plus delta mean by 2 divided by sin A by 2. To put the value of delta minimum, it becomes sin A by sin A by 2. So mu will become 2 cos A by 2, or A is given. This is the equilateral prism. So A is 60 degree. 2 cos A by 2, A is given since it is an equilateral prism. 2 cos 30 degree means becomes root 3. Okay. Now the magnetic field lines are dashed by paramagnetic substances. So actually, in case of paramagnetic substances, the magnetic field lines are increases. So laminated iron sheet are used to minimize dash current in the core of transformer. Actually, it's minimize the eddy current, because of eddy current there is loss in energy. So we use iron sheet to minimize eddy current. Now there is 1 marks question. There are so many in section A. I am going to discuss the short answer, which is for 1 marks. Section 16, question number 16. The nuclear radius of aluminium is 3.6 Fermi. Find the nuclear radius of copper. So this is question 16. R is equal to R naught A raised to 1 by 3. R naught is constant, 1.3 Fermi. Now for aluminium, the nuclear radius is given. This is 3.6 Fermi. This is the mass number. Mass number of aluminium is 27. This is 1 by 3. Now we have to find the nuclear radius of copper. So R is R naught. Mass number of copper is 64, 1 raised to 3. So take the ratio of 1 and 2. To R by 3.6, 27 by 64 raised to 64 by 27 raised to 1 by 3. This will become 4 by 3. So R will become 4 by 3 into 3.6. This will become 1.2, that is 4.8 Fermi. Now, if proton and electron have equal speed, find the ratio of de Broglie wavelength associated with them. Proton and electron have equal speed. Find the ratio of de Broglie wavelength associated with them. So for proton and electron, the ratio of mass of electron is mass of proton by almost 18-15. Okay. The speed is same. Now we have to find the wavelength. So from the de Broglie hypothesis, lambda is h by p. De Broglie wavelength associated with the lambda of proton by lambda of electron is momentum of electron by momentum of proton. Since it is inversely proportional to momentum, so speed is same. The mass of electron by mass of proton. From here you can write mass of electron by mass of proton is 1 by 1840. Now question 17. The variation of stopping potential V naught with the frequency nu of the light incident on two different photosensitive surfaces M1 and M2 is shown in the figure. Identify the surface which has greater value of work function. Okay, so stopping potential versus frequency graph is given. Stopping potential versus frequency graph is given. Two different photosensitive surfaces. This is for M1 or this is for M2. Since for M2 threshold frequency is greater than threshold frequency of M1, identify the surface which has greater value of work function. Since threshold frequency of M2 is greater than threshold frequency of M1, so work function of M2 should be greater than work function of M1. Now question 18. Why cannot we use silicon or germanium in fabrication of visible LED? So LED के लिए हम विजिबल LED के लिए सिलिकॉन और जर्मेनियम का यूज हम क्यों नहीं करते हैं? Because silicon or germanium diodes do not emit energy in the form of light. Do not emit energy in the form of light. Instead, they emit energy in the form of heat. इसलिए हम सिलिकॉन और जर्मेनियम को LED लाइट के फॉर्म में नहीं करते हैं. Question 19. Differentiate between conduction current and displacement current. So conduction current is due to the motion of electron, but displacement current is due to rate of change of electric flux. In case of capacitor or displacement current ID is epsilon naught d phi E by dt. So this is actually change of electric flux, but conduction current is due to flow of charge, rate of flow of charge. So this is the basic difference between conduction current and displacement current. Now question 20. How does an increase in doping concentration affect the width of depletion layer of p-n junction diode? So p-n junction diode, suppose this is p region, this is the depletion region, this is n region. So p region means here is holes are majority charge carrier. Holes are majority charge carrier. N region means here electrons are majority charge carrier. That is, this is the acceptor, this is the donor. In depletion region, this is the, they neutralize each other. Or there is a potential difference across, see the depletion region. So there is a potential difference across depletion region. The question is, how does an increase in doping concentration affect the width of depletion layer of induction diode? अब doping concentration increase करोगे तो depletion layer बढ़ते जाएगा, क्योंकि suppose यहाँ से होल्स इधर ड्रिफ्ट किया तो यहाँ पे क्या छोड़ेगा? देयर विल बी ए वैकेंसी. यहाँ से इलेक्ट्रॉन अगर इधर इस डिप्लीशन रीजन के इधर आया तो देयर इज ए वैकेंसी. सो दिस डिप्लीशन रीजन इज इंक्रीजेस. सो आंसर इज इट इंक्रीजेस विथ डोपिंग कंसंट्रेशन. Now section B. Question 21. Explain the term depletion layer and potential barrier in a PN junction diode. How are the width of depletion layer and the value of potential barrier affect when the PN junction is forward biased? PN junction is forward biased. The first question is potential barrier in PN junction diode. Explain the term. So I have explained little bit about the potential barrier or depletion region. My second question is value of potential barrier effect when the PN junction diode is forward biased. तो जब उसको फॉरवर्ड बायस करेंगे मतलब पी टर्मिनल को पॉजिटिव और एन टर्मिनल को नेगेटिव से कनेक्ट करेंगे तो पोटेंशियल बैरियर या डिप्लेशन लेयर की जो साइज है कम होती जाती है. सपोज दिस इज द करंट इन मिली एम्पियर, वोल्टेज इन वोल्ट. तो फॉरवर्ड बायसिंग में for silicon this is 0.6 volt and for germanium this is about 0.2 volt. Now question 22. Using Bohr model, derive an expression for velocity of electron revolving in the nth ऑर्बिट ऑफ हाइड्रोजन एटम. तो हमको वेलोसिटी का एक्सप्रेशन निकालना है हाइड्रोजन एटम्स के लिए. हम दो इक्वेशन यूज करेंगे. वन इज कंजर्वेशन ऑफ एंगुलर मोमेंटम एंड अनदर इज नेट फोर्स सेंट्रीपिटल फोर्स टुवर्ड्स द सेंटर और फोर्स ऑफ अट्रैक्शन बिटवीन द इलेक्ट्रॉन्स एंड positive charge, that is nucleus. So suppose the electron is revolving in this direction, this is the radius, or suppose I am considering here general, suppose the atomic number of atom is Jd. In case of hydrogen just put Z is equal to 1. So since this electron is revolving in a circular orbit, so net force to our center will become mv square by r. So this is equal to k Jd E by r square mv square by r. For hydrogen atom just put Z is equal to 1. Now from the conservation of angular momentum, mvr is equal to nh by 2 pi. From these two equation, take r from here. Suppose this is capital R. I put here. Final expression is v is equal to e square by 2h epsilon naught. K is equal to 1 pi 4 pi epsilon. Z by n. Z by n, we can write this is also Z by n into V naught, or V naught is C by 137, or this is approximately 2.18 10 raised to 6 meter per second. Right? So this is the expression of velocity of electron revolving in an orbit of hydrogen atom. Now explain how the process of emission of photoelectron is different from the process of emission of beta particle. The emission of photoelectron is due to incident of photons on the metal surface, but beta emission is a nuclear phenomenon in which the one neutron breaks into one neutron. Question number 22. One neutron breaks into beta, one proton. Mass number or charge number is conserved here. So beta emission is a nuclear phenomena, but process of emission of photoelectron is due to incident of photons on the metal surface. In beta emission, one neutron breaks into one electron or beta particle and proton. 23. Two long straight parallel wires A and B separated by a distance d. Diagram is given in the question. Carry equal current I flowing in the same direction as shown in the figure. First question is find the magnetic field at point P situated between them at a distance x from one wire. Question B, show graphically the variation of magnetic field with distance x. X is greater than 0, less than d. So do the first. Current is flowing in this wire. Suppose the current is coming outside. Here the current is also coming outside. Since it is given in the question, the current is flowing in the same direction. We have to find the magnetic field at point P, which is at a distance t. This distance between A and B is given. Now the magnetic field due to this current which is coming outside or which is coming perpendicular to this surface will be in this direction, ideal cross R. Because of this, the magnetic field at this point will be ideal cross of R in downward direction. So net magnetic field at P because of this mu naught I by 2 pi x. Since it is an infinite wire, because of this the magnetic field at this point will become mu naught I by 2 pi d minus x. Now take the common terms. Mu naught I by 2 pi 1 by x minus 1 by d minus x. So d will becomes mu naught I by 2 pi d minus x minus of x d minus x. So it will become mu naught I by 2 pi d minus 2x d minus x. The first question is about to find the expression of magnetic field. Second question is show graphically the variation of magnetic field with the distance x is greater than 0 and d is question B, x is greater than 0, less than d. Now we have to plot the b versus x. This b versus x. This is b, this is x. But x is equal to 0, this will become d and this will become 0. Means b is infinite. At x is equal to d. So b will become x is equal to d, this is become minus d and this is 0. So it tends to minus infinity. So we have to plot between x is equal to 0 and x is equal to d. It is given in the question. So at x 0 plus it tends to infinity. At x is equal to d by 2 it will become 0. At the midpoint between A and B, the magnetic field becomes 0 because current in both the wire is same. So the graph will look like this. It will pass through the midpoint. So at x 0 plus, it will tend toward positive. At x is equal to 0, it will negative. Now question number 24. Define wave front of a travelling wave. So wave front means it is the locus of point where all the particles are vibrating in same phase. Now next question is using Lenz-Maker formula derive the write the thin lens formula 1 by f is equal to 1 by b minus 1 by u for a biconvex lens. Means we have to find the expression for lenses. Or lens formula, we have to find the expression for lens formula. So this is question number 24. Suppose I am considering for convex lens. Suppose the refractive index here is mu1, the refractive index of lens is mu2, and refractive index on the other side of lens is also mu1. As you know that refraction from the curved surface, suppose this is mu1, this is mu2, and radius of this curved surface is r. Then from the refraction from this surface, the refractive index left to this curved surface is mu1 and right to this curved surface is mu2. So this is mu2 by v minus mu1 by u, mu2 minus mu1 by r. R is the radius of curvature of this curved surface. To use this formula for twice for this lens, one for this curved surface, one for this curved surface. Suppose the radius of this curved surface is, center of curvature is here. For this, the center of curvature is here, and the radius for this is r1, radius for this is r2. So use this twice for this surface and add them. Finally we will get 1 by b minus 1 by u in mu2 by mu1 minus of 1, 1 by r1 minus 1 by r2. Now the question is about one length formula. As you know that for how to define focal length means the ray which is coming from the infinity, that is which is parallel to the principal axis. After refraction from the lens, it passes through the focus of lens. That is, if u is equal to infinity, that is rays are parallel, v becomes f. So you can put here, suppose this is the equation 1 by f, it becomes 1 mu2 by mu1 minus of 1 by r1 minus 1 by r2. So from 1 and 2 we can write 1 by f is equal to 1 by b minus 1 by a. Right? The next question is question 25. Define the terms half-life of a radioactive substance. Two different radioactive substances have half-lives T1 and T2, and number of undecayed. Undecayed means the nuclei which is present right now, atoms at an instant N1 and N2 respectively. Find the ratio of their activities at that instant. The first question is define the half-life. Half-life means it is the time when number of nuclei of a radioactive substance becomes half. You have to write it in simple way. When the nuclei of radioactive becomes half. Now second question is find the activity of at that instant. So activity means number of decay per second. Number of decay per second. I hope everyone know. dN by dt is lambda into n. Lambda into n. N is the number of nuclei present at any moment, means undecayed nuclei. It is given N1 and N2, and lambda is 0.693 by T half into n. तो for first nuclei activity is 0.693 by T1 into N1. For second it becomes 0.693 by T2 into N2. Now you have to just find the A1 by A2. It will become N1 N2 by T1 into T2. Okay. Now question 26. The space between the plates of the parallel plate capacitor is completely filled in two ways. In the first case it is filled with a slab of dielectric constant K. In the second case it filled with two slabs of equal dimension but different dielectric constant K1 and K2 respectively as shown in the figure. The capacitance of the capacitor is same in two cases. Obtain the relation between K, K1, K2. So diagram is given, just we have to find the relation between K, K1 and K2 for two different configurations. So parallel plate capacitor, it is filled with a dielectric of dielectric constant K. Dielectric constant K. Suppose this is the terminal A, this is the terminal B. This is given. Now the capacitance of this capacitor will become K times A epsilon naught by D, where K is the dielectric constant, A is the cross-sectional area of parallel plate. Now diagram 2 is, it is divided equally in two halves. Here is dielectric, here is another dielectric. The dielectric constant of this is K1 and this is K2. Length of this is L by 2, L by 2. Now we have to find the equivalent capacitor across AB. So this is the same diagram you can draw like this. Two capacitors are connected in parallel. The cross-sectional area of this becomes A by 2 and dielectric constant here is K1 and dielectric constant here is K2. Suppose the capacitance of this capacitor is C1 and this capacitor is C2 and both are connected in parallel. Area of cross section of each capacitor becomes half in this case, since it is equally divided into two parts. Suppose the capacitance of this capacitor is C1 and capacitance of this capacitor is C2. C1 is K1 times A epsilon naught by 2D. A by 2, this the distance between a gap between two plates is D. Now area becomes half. D is same, or this is K1. K2 is K2 A epsilon naught by 2D. Now both the capacitors are in parallel, so C equivalent is C1 plus C2. Suppose this is C. Now put K1 A epsilon naught by 2D, K2 A epsilon naught by 2D, take common 2D, K1 plus K2, or this capacitance is equal to the capacitance of this capacitor, so this is equal to K epsilon naught by D. So you can write K epsilon naught by D here. K 2K will become K1 plus K2. This is the relation between K, K1 and K2. So this is about the question 26. Now question 27. Explain the principle of working of meter bridge. Draw the circuit diagram for determination of unknown resistance using it. Actually, the principle of meter bridge is balanced heat stone bridge. So just we have to write the principle is balanced heat stone bridge. Suppose I have a meter bridge having uniform resistance per unit length. We have two resistance one unknown resistance R1 and R2. Suppose this length is L1, this length is L2. Now it is connected to a battery. It is connected to a galvanometer. By using rheostat, we find a point such that the current through this galvanometer becomes zero. A length at that moment is this is L1 and this is L2. If we know the resistance R2, by using the heat stone bridge we can find the resistance R1. So R1 by L1 becomes R2 by L2. So this is about the question 27. Now section C. So write the expression for the speed of light in a material medium of relative permittivity epsilon r and relative magnetic permeability mu r. I hope everyone knows the speed of light